The multiplication principle of equality works very similar to the addition principle of equality. Again, the idea is we want to isolate the variable, get the variable by itself. Therefore, if something is multiplied to our variable, to remove it, we do the opposite of multiplication, which is divide. Remember again, since it's an equation, to keep everything the same, if we divide on one side of the equation, we must divide on the other side of the equation. Here's an example of how I can use the multiplication principle of equality in order to isolate my variable and solve for my variable. This problem, if you think about it, says 3 times a number gives me 12. What is the number? Intuitively, you should know that this number should be 4, so 3 times 4, because 3 times 4 gives me 12. But let us do this problem algebraically in order to find out to solve for this x. The principle remains the same. We are trying to isolate the x, to get the x by itself. Therefore, anything that is around the x, we try to get rid of. And whatever is done on one side of the problem, we try to do exactly the same thing on the other side of the problem. Notice that this 3 is multiplied to the x. Therefore, to get rid of the 3, I need to do the opposite of multiplication, which is division. So I divide by 3. If I divide by 3 on this side of the equation, I must divide by 3 on the other side of the equal sign also. Notice how it cancels out. This 3 cancels out this 3, so I'm left with just x, which is exactly what I wanted in the first place. So I have x here. Equal sign comes back. And then this 3 cancels out the 12, so I get a 4. So x is 4, which we had already known. We could demonstrate this principle with another problem, which might not be so straightforward to see the answer quickly, but the technique remains the same. Here's our second example. 2/3 y is equal to 5/9. Problems ask you, what is y? Remember again, the 2/3 is multiplied to the y. So I need to get rid of the 2/3. So I need to divide by 2/3, since the 2/3 is multiplied by the y. But remember a very important part of fractions. If I am multiplying by a fraction, if I'm dividing by a fraction, it is the same thing as multiplying by the inverse of the fraction, meaning that I can multiply the fraction by its upside down to get my division. So dividing 2/3 by 2/3 is the same thing as multiplying by 3/2. Remember, if I do this on one side of the equal sign, I must do exactly the same thing on the other side of the equal sign. And notice how nice it works out. Remember again, what I'm trying to do is get the y by itself. So this 2 cancels out this 2. This 3 cancels out this 3. So I'm just left with my y. My equal sign comes back. And now I have 5/9. I could cancel also 2. 3, this goes once, this goes 3 times. So 5 times 1 gives me 5/3 times 2 gives me 6. So y is 5/6. Last example. -7x equals 21. What is x? We apply our same principle, and our principle is that we want x by itself. If I want x by itself, there's a -7 multiplied to the x. So since this -7 is multiplied to the x, I need to get rid of it. To get rid of this -7, I need to divide by -7, since division is the opposite of multiplication. To keep my problem the same, I do exactly the same thing on the other side of the problem. Divide by -7 also. And when I do that, Notice how the negative 7 cancels out this negative 7, which leaves me with the x, which is exactly what I want, x by itself. Equal sign returns, so the equal sign comes back. And then 21 divided by negative 7 gives me negative 3. Therefore, x is negative 3. And important now we can do, we can always take our number and put it right back in the original problem to see if we get back this answer. So for example, if I take negative 3 and substitute it for x, negative 7 times negative 3 gives me 21, which makes me know that I have the right answer.